So this is an explanation of the calculations for part 1 of the thermochemistry lab. So in part 1 of this experiment, you prepared the calorimeter, you added some cold water to it, you weighed the cold water, you had some hot water, well, before it was hot you weighed it, and you added the hot water to the cold water, you measured the change in temperature. So what's happening here is all the energy that came out of the hot water, this Q hot, went into two places, the cold water and the calorimeter. So we write that as minus Q hot, minus because it's coming out, the energy is coming out of the hot water, is equal to Q cold plus Q of the calorimeter. Where Q hot, the thermal energy being transferred into or out of the hot water, is equal to the specific heat capacity of the hot water, S, times the mass of the hot water times the change in temperature of the hot water. Likewise, Q of the cold is S times mass of the cold times delta T of the cold. And Q of the calorimeter, we don't know the specific heat, and we didn't weigh the calorimeter, but we can write the Q calorimeter as just the heat capacity, not the specific heat capacity of the calorimeter, times the change in temperature of the calorimeter. C is going to be called our calorimeter constant. Our goal in this part of the experiment is to determine the calorimeter constant C. So the way we do that is we substitute in for each of the Q's what they mean, Sm delta T for the hot, Sm delta T for the cold, and C delta T for the calorimeter. Rearrange this equation solving for the heat capacity of the calorimeter constant C. We get this equation right here. So in order to plug into this equation and get what we need, the specific heat capacity, the heat capacity of the calorimeter, we need to know what these numbers are. The specific heat of both the hot and the cold water, is 4.184 joules per gram degree Celsius. The change in temperature of the hot water is the final temperature minus the initial temperature of the hot water. The initial temperature of the hot water you measured in the lab. You'll see in the procedure. The final temperature you get from the graph, I'll show you that in a separate video. Notice the final temperature appears in all three of these delta T's, and it is exactly the same number. Delta T of the cold water is equal to the final temperature minus the initial temperature of the cold. You get the final temperature from the graph, the initial temperature you measured in the lab. Delta T of the calorimeter is the final temperature from the graph minus the initial temperature of the cold water. Because the cold water was in the calorimeter, we're assuming that they started out at the same temperature.